In this video, we're going to put together our authentication API endpoints for our website. So if you guys recall from the overview video we did at the beginning of this series, or this chapter of the MMO project for our launcher, you'll remember that we need to do two things related to authentication from within our launcher. Now, when we open the launcher, the first thing I wanted to do is ask the user for a username and password. Then it's going to validate those credentials against the website to ensure that the user is ensure that they exist, and B, that their roles allow them access to the game. If both of those things are true, then the launcher will go out and do its launchy type things, such as query for the latest client, download it, and unpack it. And then after that's all done, we want the launcher to launch the client. Well, the launcher wouldn't be very useful if it didn't launch the client, but it needs some way to kind of marshal the authentication. What do I mean by that? Well, the launcher is going to launch the client, but I don't want the client to also ask for a username and password. We've already established that they logged in with their username and password from the launcher. We shouldn't have to re-ask the user once they actually launch the game for their username and password. So how do we do that? Well, the way that I came up with is to hit the API again once the launcher actually performs the launching of the client, and have the web API generate an authentication token. So just a random token. We'll just be using our RNG crypto service provider and our base64 encoding, and we're going to create a random token, a random string of data that will be passed back to the launcher once the launcher is actually performing the launching, and then the launcher will pass that token into the client as a command line parameter. The client will pick up on that command line parameter and then pass it to the server, the Photon server, to authenticate himself. So again, the launcher, after it downloads the client but before it launches it, it's going to hit the API again, generate a token. The API will generate a token, add it to the database. It'll return that token to the launcher. Then the launcher will execute the client or run the client with that token as a command line parameter, which will then be used to hit Photon and authenticate the user. Now we could certainly bypass this step and instead write the username and password to a file that the client can pick up on, so the client could resend its credentials. I don't really like that. I don't want our well, we will be having passwords hit the file system at some point, but that solution seems rather inelegant to me. An alternate solution would be to pass the username, have the launcher pass the username and password to the client as a command line parameter. I don't really like that either, because then you can just open up your task manager and you can see your username and password just sitting there in your task manager, because your task manager will show command line parameters if you tell it to. I don't like that idea because that it wouldn't really be an expected thing to do. I mean, ultimately, at the end of the day, if a person has access to your computer physically, you are already as compromised as you could ever get as far as a security perspective goes. So I don't really mind username and passwords hitting the file system or being in memory somewhere, because like I said, if someone's sitting at your computer and you're not watching over what they do, they can just install a keylogger or something. So in that case, you're already compromised. So like I said, I don't mind throwing passwords around, but I don't want your password to show up somewhere unexpected, such as the task manager. So instead, we're going to build a really simple token authentication thing, and we've written 3 different systems that use tokens so far, so it should be pretty straightforward to implement. It will, however, require us to create a new entity, and that new entity will be used to store the token information in the database. It'll be consumed both by the website and by the Photon server itself. So let's go ahead and do that. So to create our entity, we jump into our data project, because remember, we want to share these classes between our Photon server and our website. And under the entity's namespace, I'm going to go ahead and create a new class. I mean, there's actually a variety of ways I can do this. I could add this as a field onto our user, but I kind of don't want to do that, and the reason I don't want to do that is I want the token to include the IP address that was requested, and I also want the token to include a date time. And our user class is kind of getting a little bit big. In fact, at some point in the future, I might even take these parameters out of my user entity and put them into a different entity. I don't want the user entity to get massive because then it starts causing some maintenance issues. But so instead of adding the token directly as a property to our user entity, let's go ahead and create another entity. Let's call this entity, let's be uninspiring and call this an authentication token. Actually, let's call this a client authentication token, because there might be a variety of different things that we might call an authentication token in our system, so let's go ahead and qualify it as a client authentication token. Now, of course, we need a public int ID. We need a primary key for this table. We'll, of course, need our token. Our token will be required, and it's also going to have a max length of 64. I think the length that we established for our verify email and our reset password tokens, I think that length is good enough as far as cryptographically randomly generated numbers, as far as I'm concerned. So after we do that, we'll need a public string request IP, which will be required. The request IP, I can't remember what length I decided IP addresses to be. I decided they should be 64. That's just so that we can handle both IPv4 and IPv6. Because obviously IPv6 is considerably longer. So we don't want to constrain it to just being a request IP of 4 bytes. I suppose I could encode this into some sort of binary data. In fact, that might even be better, but let's just leave it as string data for now. In the future, we might refactor everything that we deal with IPs into binary data, because then, like I said earlier in a previous video, IPv6 addresses can be represented in a variety of different ways, and doing a string comparison between an IPv6 and another IPv6 address might not work, even if they're equivalent, based on how they were formatted to begin with. But let's just leave it as strings. Make it simple. Okay, so we have our request IP. We'll also want to know when this token was created at. So date time, which will bring in the using system, and we'll call this created at. And another thing that we'll need is a public user. We'll need to know which user was responsible for creating this authentication token. And I'm going to mark this as a required field as well, so that we get a nice foreign key constraint as well as a not null in our database. So that's our ID, our token, our request IP, our user, and our created at. I am not going to be enforcing or I'm not going to be storing or keeping existing client authentication tokens around. I'm going to try to write code that'll clean up this table as we go along. So if a user requests another authentication token after they've already created one, their old one will be destroyed, just to keep the table a little clean. You might, for auditing purposes and maybe even security purposes, you might want to add some sort of log of authentication tokens that were created. Of course, that's something that we could add later, but for now I want to keep things simple. Okay, so now have this entity done. In order to create the migration that'll add this table to our database, we of course have to jump into our database context and reference it there. So to do that, we jump in here and we add a new public DB set. And this can be client authentication token, and we'll call this client authentication tokens. Again, a very uninspiring name, but it makes things clear. I'm starting not to become a fan of this concept of a DB context. I wonder if it's possible to split up our DB contexts into multiple DB contexts so we don't have all of these entities being added as public properties on the same object. We'll look into that later, probably, especially when we get into unit testing, where we'll have to actually mock this particular thing out so that our unit tests aren't always hitting the database, which, oh man, yeah, that gets into a big can of worms. There's recently this big debate between DHH, Martin Fowler, and I think Kent Beck, I can't remember his name, about TDD, and in particular, if you should be hitting databases in your tests or not. But you guys should definitely check those talks out. They're over on the ThoughtWorks YouTube channel. Anyway, so stuff and things. We now have this entity added to our DB context, which means if we go ahead and open up our package manager console and create a migration, it'll create a migration for this entity. Okay, so let's open up our package manager console. Let's make sure our default project is set to buzzmmo.data so that we're using this database context. And then let's add a migration for create client authentication tokens and hit enter. And I messed up on the U there. That's going to, oh, and I also misspelled client. Wow. I can type, I swear. But that just means instead of like worrying about trying to rename this, because I don't know on this migration framework where it uses names and where it doesn't use names and how they're referenced to each other. So I really don't want to update the name of this class without fully understanding how its magic works. So instead of trying to get the rename done, I'm just going to delete this migration wholesale, come back to the package manager console, and add it again with the proper name. So it's going to be called create client authentication tokens. And the casing looks good, the spelling looks good, so let's go ahead and get that generated. All right, so that's done, but we're not quite finished. You'll see that we do indeed have our IDs, its identity column, blah, 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 nullable, max length, proper types. All that stuff is good. User ID has a nullable of false. That's good. We also see that it did generate a foreign key for our DBO users, which is also good. And it did index our user ID. The last thing I want to do is I also want to provide a unique index on our token itself, which will be unique. I want to make sure that we index the token so that we can efficiently query for tokens. And I want to make sure it's unique just so that we don't accidentally generate two similar tokens ever. Now, the likelihood of that happening is incredibly small, and if I wanted to put a little bit more work into this, I could reduce that likelihood to 0. But in this particular case, simply adding a sanity check on our database, making it so that we can never have two tokens that are identical, will be good enough for our purposes. And if it ever becomes not good enough for our purposes, well, then we can look at that later. Now that we've done that, we have our migration created. Let's open up our package manager console, and let's say update database, which will run our new migration and give us a new table. And we get an error. What do we get? Blah, blah, blah. Can't find file. Rules.frm. Oh, that isn't good. That's really not good. I've been having problems with one of my hard drives in my computer. I honestly can't remember. Did I dump my MySQL onto that hard drive that I'm having problems with? If so, then we might have a slight emergency on our hands. Otherwise, it's just something I did with the code. But I'm going to leave this on video just in case this is something that will happen to all of you guys so we can see how we would go about debugging this. Again, the first thing is I'm off screen right now, just making sure. Nope. Funny enough, that the drive that's almost failing is mostly a backup drive, so that's good. Well, in that case, I'm out of ideas. So what I'm going to do is what any good developer would do, is try it again. and we seem to get deterministic results, which is unfortunate. Cannot find file user roles.frm. I'm going to fire up MySQL Workbench, and I'm going to try to hit some queries against my database and see if that works. I am able to query roles. I am able to query user roles. Okay, I'm able to query all the tables. This doesn't look like it's corruption. So what I am going to do is I'm going to show a very useful debugging tip when working with migrations. You'll notice that it says specify the verbose flag to view SQL statements. So that's exactly what I'm going to do. I'm going to say verbose. What this is going to do is it's going to give me what? Huh? What is this madness? Using startup project buzzmo.webgood, using NuGet project buzzmo.datagood, target database is buzzmo2 good, adding explicit migration. Oh. What? Okay, well for some reason it's trying to rename my user roles to role users. I don't know why it would want to do that. That seems like a very silly thing to do. And you see right here, it is indeed, it says rename table user roles to role users, and then I'm getting an exception about cannot find file. I don't know exactly why I'm getting that. But what I will do is I don't want to rename my table user roles to role users. I don't know why it's doing this to me. Seems like something about me adding a client authentication token that referenced a user has affected the user's relationships with their roles. I wonder if, because I didn't create a bidirectional relationship between client authentication token and user, the system is getting confused and just throwing up a miserable migration that should never have been made. So I'm wondering if I add the other direction of this entity to this relationship, if it'll work. I think that might be what it did, because we are using convention-based mapping right now. So what I'm going to do is I'm going to try to add the other end of this relationship to my user entity, and if that works, then I'm going to see if I could use explicit mapping to not have to do that bidirectional relationship, because, yeah, that seems like it'd be silly. So let's go ahead and do that. On my user entity, I'm going to say public virtual iCollection of client authentication tokens, and we'll call this client. We'll just call this client tokens, give it a little shorthand. Then I'm going to delete this migration, create client authentication tokens. I'm going to open up my package manager console, and I'm going to re-add this migration, and I'm going to see if it's still trying to do that dumb thing with user roles, and it is. I don't know why it's doing that to me. See, it renames it, it drops its primary key, and then it adds its primary key back. It's really bizarre. So I think what we're going to do is, instead of worrying about trying to coax Entity Framework into figuring out our model the way we want it to, I'm just going to go ahead and explicitly tell it, I want there to be a many-to-many relationship between users and roles, and I want that table to be called user roles. I don't want you to rename it. I don't want you to drop the primary key and add it back again for some reason. I mean, this is so weird what it's doing. It's renaming the table, it's dropping its PK, and then it's re-adding it as a compound PK. Was it even a compound PK to begin with? Yeah, it was. Okay. Wow. Yeah, basically we just really confused Entity Framework. So it's important to know how to be able to fix these cases where Entity Framework is not capable of extrapolating the information we want it to out of our model code. So let's go ahead and delete this migration one last time and jump into our database context and then jump down to our on-model creating. Remember, our on-model creating allows us to override any of the mappings that Entity Framework created for us by default. Now what we're going to do is we're going to map a many-to-many relationship between users and roles, and we're going to enforce that the table it's going to use is called user roles. So the way we do this is we say mapping.entity. We'll want to start off with our user entity. This should work either way around, actually, since it's a bidirectional many-to-many. Then we're going to say dot has many. We're going to pass in an expression that goes into roles. Then I'm going to say dot with many. Now, with many is the opposite direction for our bidirectional many-to-many. So user to roles, and then the with many is going to be roles to users. So we pass in an expression that goes roles to users. Then now that we've told Entity Framework we really want a many-to-many relationship between roles and users, I want to enforce the specific table name so it doesn't go off and do something stupid like try to rename user roles into roles users, which is a really silly thing to do in the first place. So I'm going to say .map t goes into. I'm going to open this up in a block because I generally do that. Sometimes I don't, sometimes I do. I think stylistically it'd be better if I did this on a single line. Then I'm going to say t.toTable, passing in a table name of user roles. Actually, I might want to capitalize this. In MySQL, database or table names are lowercase, but if we capitalize it, it just looks better, but it won't make a difference, basically. Okay, so with this tiny little bit of code, we have now enforced a many-to-many relationship between users and roles, and we've given it an explicit table name, and this should prevent Entity Framework from being dumb. So let's go ahead and open up our package manager console. I'll leave that code up there on the screen if anybody wants to pause the video. And then I'll jump up and I'll say add migration, create client authentication tokens for the 57.2nd time or something. I don't know if you can use that sentence. That is poorly English words. And we get a migration, and we see that there is no garbage about changing our user roles table to a roles user table, which is exactly what we want. But we shouldn't forget that we definitely do want to create that unique index on our token property. So let's go ahead and jump down to the end of our create table statement and do dot index. We'll select our token property and we'll pass in a parameter of unique equals true. So now that we've done that, let's open up our package manager console again and type in update database, hopefully for the last time in this video, because we do indeed get no errors. Sweet. Now let's go ahead and jump into our MySQL workbench and make sure that that table was created properly. Let me go ahead and say refresh all. We see we indeed have a client authentication tokens table. And we can take a look at it, and we can ensure that we do indeed have a foreign key with our user ID. We do indeed have a unique constraint on our token, and we do indeed have not nullable fields, which is exactly what I wanted. Maybe in the future I might go and change the way I name tables, since pretty much, I mean, you can do a lot of cool things with Entity Framework. I could go in and change the default convention of table names to include underscores so that words are separated by underscores as opposed to all being clumped together. I might do that in a later video, but for now we're just going to keep it client authentication tokens, all one word. So jumping out of that, we now have our entity. Finally, we have our entity. So now we can focus on what we are going to be doing with our authentication API.